Hi everyone, this is Mrs. Snowbeck. Today we are going to cover Unit 5, Lesson 2. And we're going to be talking about what does it mean if two shapes are similar to each other. So similar polygons or similar shapes, it means they have the same shape but different sizes. Same shape but different size. So maybe you have a larger pentagon and a smaller pentagon. They might be similar to each other, but they are not congruent to each other. And the symbol for is similar to is a squiggle. So if you see a squiggle, that means two shapes are similar, the same shape. Now, if two polygons are similar, their corresponding angles will actually be congruent. So the angles will be the same sizes, but their corresponding sides will be proportional. Proportional. Let me show you what I mean by this. Look at angle A in the quadrilateral on the left. See how it has one curve? Well, over here, angle W also has one curve. So that means angle A is congruent to angle W. They are the same size. Check out angle B. Angle B has two curves. Well, so does X. And so angle B is congruent to angle X, exactly the same size. So like if this is 80 degrees, this is 80 degrees. If this is 100 degrees, this is 100 degrees. They're the same size angle-wise. Angle C is congruent to angle Y. Angle D is congruent to angle Z. Now let's talk about the sides. You can see the sides are not congruent. For instance, look at AB and look at WX. 15 does not equal 5. But if we divide those, if we divide 15 divided by 5, we get 3. Take the next set of sides, the 12 and the 4. If we do 12 divided by 4, we get 3. Take the next set of sides, the 21 and the 7. 21 divided by 7 is 3. Take the last one, 18 and 6. 18 divided by 6 is 3. Look what we got. We got 3, 3, 3, 3. That means they all have the same ratio to each other. And so the two shapes are proportional. And so if we wanted to write a little statement relating the sides, we could say something like this. If we take AB and divide it by WX, we get 3, right? So it should be equal to the same thing we got when we did BC divided by XY. And it's the same thing we got when we did CD divided by YZ. And it's the same thing we got when we did DA divided by ZW. So this is a proportion relating the sides. Now finally, we do know that these shapes are similar because all their angles were congruent, all their corresponding angles were congruent, and all of their corresponding sides were proportional. So our similarity statement can be something like, oh, ABCD is similar to WXYZ. And notice how I use that little squiggle in there for is similar to. Number 1, triangle FGH is similar to triangle JKL. List all the pairs of congruent angles and write a proportion that relates the corresponding sides. So you know what, you guys, I don't even look at the picture. I look at this statement right up here, and I can see angle F is listed first. So angle F right here is going to be congruent to the first letter over here, angle J. The middle letter, G, so let me underline G is in the middle, is going to be matched up with K. And so angle G is congruent to angle K. And finally, the last one, angle H, is congruent to angle L. So there we have the angles. Now we have to write that proportion that relates the sides. So remember, like for instance, if I take side FG, they're the first two letters, are going to match up with JK. So I don't even look at the picture usually. I just use these letters up here, and I can say something like FG, the first two letters, divided by JK, the first two letters. Whatever I get there, I'm going to get the same thing if I do GH divided by KL, so the last two letters divided by the last two letters, and then also the first and last. So how about like FH divided by JL? So there we have it. We have our pairs of congruent angles, and we have our proportion that relates the corresponding sides. Next, let's talk about scale factor. So scale factor is the ratio that compares the two sides. So the ratio between corresponding sides in similar figures. The ratio between corresponding sides in similar figures. Remember how we did that first example and we divided the sides and we got 3, 3, 3, 3? Well, 3 was the scale factor. So basically, if you divide the sides, what number do you get? That's the scale factor. Number 2, in the diagram, triangle ABC is similar to triangle XYZ. Find the scale factor. Well, I see a number right here. I see a 6 on AB. Now, AB are the first two letters. It should match up with XY, the first two letters. Well, XY is 3. So the scale factor is 6 to 3. Now, you have to list them in order. You have to have the ABC one first, which is right here. It's 6. And then the XYZ one second, which is 3. Now 6 divided by 3 is 2. You should always simplify, so the scale factor is 2. Now find the scale factor of XYZ to ABC. So now we're going to put them in a different order. We need XYZ first, so now we need the 3 first, and then ABC second, so 6. So this time the scale factor is 1/2. So order matters. They compare 2 to 1 or 1 to 2, depending which way you're looking at it. Number 3, determine if these triangles are similar. If so, write the similarity statement and the scale factor. All right, so first we're going to check the angles. So check the angles. Okay, so I can see angle N has one curve. It's congruent to angle R. Angle Q has two curves. That's congruent to angle S. So that leaves angle P, and the third angles would have to be congruent because they'd have to add up to 180. So even though they're not marked, I do know they're congruent. So the angles work. So the next thing I'm going to do is I'm going to check the sides. Now think about the sides in this triangle. In the one on the left, the 15 is the biggest number. Between 15, 12.5, and 11.5, 15 is the biggest number. In the other triangle, 12 is the biggest number. So what I'm going to start with is I'm going to do 15 divided by 12. Now I'm going to have to grab my calculator, and I'm going to type in 15 divided by 12, and I get 1.25. Now I'm going to pick another set of sides. So next I'm going to pick, let's pick the middle length. So 12.5 is like the middle size between 15 is bigger and 11.5 is smaller. In the middle over here would be the 10. So let's write this down. Let's do 12.5 divided by 10, because they correspond with each other. And so if I divide those on my calculator, I get 1.25 again. Let's try the last side. So the last side we have is the shortest side. The shortest side here is 11.5. The shortest side here is 9.2. Now 11.5 divided by 9.2, this doesn't seem like it's going to work, but let's check it. Try it in your calculator. Wow, it is 1.25. Look, we got the same number all 3 times. So guess what? Are these similar to each other? Yes. So we could say yes, and then our similarity statement could be something like triangle NQP is similar to triangle. Now we have to list them in the right order. So since I started with N, now I have to start with R, Then I went to Q, so now I have to go to S because it has the same markings, and then T. And then the second thing it wants to know is what is the scale factor. So we'll say the scale factor is 1.25. Marissa wants to use the rectangular photo shown as the background for her computer's desktop, but she needs to resize it. Determine whether the following rectangular images are similar. If so, write a similarity statement and a scale factor. Okay, so she has this 8 by 10, and she wants to figure out, could she resize it for her computer screen into a 15 by 12? Well, what I would do is take the matching sides, like for instance, this 15 and this 10. Okay, so do 15 divided by 10, you get 1.5, and then do the 12 and the 8. 12 divided by 8, yeah, you also get 1.5. So those would be similar. So would this picture work? This would be a yes, and the scale factor would be 1.5. How about the other picture? The other picture, we're going to take 14 and 10. So 14 divided by 10 is 1.4. And then we'll take 12 on the side here and 8 here. 12 divided by 8, that's 1.5. So are those similar? We would say no, not similar. We did not get exactly the same answer, so then we don't need a scale factor. Number 5, I really like this question. In the diagram, ACDF is similar to VWYZ. Find the value of x. Okay, so x is right here. Now x is between F and D. F and D, if you look up at the top, are the last two letters. It should match up with YZ. YZ is 10. Does that mean x equals 10? No, they are not equal to each other. One of these is smaller than the other. So what you have to do is set up a proportion. Now, I see this 6 right here on WY. WY are the middle two letters. It should match up with the middle two letters over here, which is CD, which is the 9. And so now we can write our proportion. We can do something like the 9 over the 6 equals the x over the 10. So you have to go like left over right equals left over right. And now you have a proportion, and we know how to solve proportions. We cross multiply. So we're going to cross multiply. 6 times x is 6x, and 9 times 10. So 6x equals 90. Divide by 6, and x equals 15. Perimeter. Remember, a perimeter is the distance around a figure, around the outside of a shape. So if you have two similar polygons, then their perimeters are also going to have that same scale factor between them. Let's do an example. Number 6. If ABCDE is similar to PQRST, find the scale factor and the perimeter of each polygon. So it's telling us they are similar. Okay, so I can see some of these marks, like right here I have a 4. Well, this would also have to be 4 because of the double tick marks. Up here, this would have to be 8 because see how the single tick mark here and the single tick mark here, they would have to be the same. So right away, I can fill in a couple of things. And if you look closely, I have the entire pentagon on the left here. I have all of the sides. So go over to the other pentagon. On this one, all I have is a 3. So what matches up with the 3? The 4. So the scale factor is 4:3. Because this side right here matches up with this side right here. Now the perimeter on the left, I can find this already because I have all the sides. I'm just going to add up all the numbers around the object. So 8 plus 8 plus 4 plus 6 plus 4. I'm going to add all of those together, and that turns out to be 30. So there's no label here, so we'll just say 30 is the perimeter. Okay, but we still need the perimeter of the one on the right, of RSTUV. We still need the distance around this one. And so what I'm going to do is I'm going to use my scale factor, and I'm going to use the 30 also. So I know the distance around this one is 30, and I want to find the distance around this one. So I'm going to go, well, the scale factor is 4 to 3. So 4 over 3 equals 30 over x. And I'll just use x for my other perimeter. So cross multiply. 4 times x is 4x. 30 times 3 is 90. So you have 4x equals 90. Divide by 4. And I think you get x equals 22.5. So 22.5 would be your other perimeter. All right, last question. What I want you guys to do is I want you to pause the video here, and I want you to try number 7 on your own. And when you're done with number 7, then unpause the video, and I'll work through it and you can see if you got it right. So go ahead, pause the video. So first thing I did is I figured out this is 4 and this is 7 because of the tick marks on there. I can also figure out this is 10.5 because of the double tick marks on that figure on the right. So the scale factor, if I look at what matches up, I can see like this 4 and this 7 match up. So the scale factor is 4 to 7. So we have that. Now we have to find the perimeter. Well, the problem is I don't know all of the sides yet of one of the objects. So what I'm going to do is I'm going to set up a little proportion like 4 over 7, and now I'm going to use this down here, this 6, and I'm going to try to figure out this side. Okay, I'll call this side x. So 4 over 7 equals 6 over x. And I can cross multiply. So 4x equals 42. Because 6 times 7 is 42, divide by 4, and x is 10.5. Which means, I'm just going to erase this down here, which means this down here is 10.5. Hey, now I have all the sides on this pentagon. So I can find it, I can find the perimeter by adding 7 plus 7 plus 10.5 plus 10.5 plus 10.5. I'm going to add all of those up. And when I do that, I get 45.5. And again, I don't think I have a label, so we'll just leave it 45.5. Well, now I have to find the other perimeter. But do you see, I have a couple of things here. Do you see how all of these, let me circle them in yellow. All of these are 10.5, 10.5, and 10.5. They're all the same. Well, that means on the other pentagon, since I have a 6, this is going to have to be 6, and this is going to have to be 6. They're going to have to all be the same if it's similar. So now, look, I have all my measurements. I can add 4 plus 4 plus 6 plus 6 plus 6. And I should be able to get the perimeter of this one. That adds up to 26. Pretty tricky, but keep trying. You'll get them. Great. Will you please now try Unit 5 Practice 2? If you get stuck, no problem. Just send us a Schoology message and we'll get back to you. Have a great day.